What's going on, everybody? It's Mr. Gustin. I am in the physics conference room right now. We're doing some circuits. So today we're discussing light bulbs in series and how switches might affect what's going on. So we discussed in class a little bit that switches are basically a wire that when the switch is closed or down, really on, it allows current to flow through it. So switches basically change whether or not current flows through a circuit or not, or at least part of a circuit. If you think of your house as one big circuit, switches control the electricity, the flow of current to different parts of your house when switches are on or off. They're different than dimmers, but they are a way to control the flow of current. So what I have in the classroom or on my table right now is I have this set up. I've got my battery eliminator, my voltage source right here. It's going to send current through 3 light bulbs in series and then back to the battery. Our job is going to be, I also have got a switch left open right here that I can close. It's in parallel with this here, this middle light bulb, but I can open and close that, right? Our job is going to be to figure out what happens when the switch is open in terms of current and voltage, and then close. And then we'll change the circuit a little bit and measure that. But we want to see what happens to the differences. One thing that we can measure with our eyeballs with light bulbs is brightness. So brightness, remember, is a measurement or is a visual indicator of the power that each of these light bulbs is dissipating. So to remember what power is essentially the amount of current times the potential across that light bulb. So power is directly related to brightness. The more power that light bulb is dissipating, the greater the brightness. So it'll be brighter. So let's go ahead and look. So I've got my power supply. I'm going to try to set this up as neatly as possible, but essentially here is what I have. I've got 3 light bulbs. I want to get them on screen. Here's the power source. I've got my switch open, and I've got my wire coming through into the first light bulb, into the second light bulb, which is right here, harder to see, but right here. The third light bulb is over here, and then my switch is in parallel. So when I turn this thing on, I'm at 6 volts right now. When I turn this thing on, you can see all the light bulbs turn on. And just like any high school kid should and would do, I'm immediately going to test this switch. So when I turn the switch on, what I notice is that this bulb goes out, and those 2 other bulbs get brighter. So there's something unique happening there. I understand that when I close this switch, the power at each of those is increased, but I don't know the measurements. So let's go ahead and take some measurements. I'm trying to back this sucker up, raise up the camera a little bit. There we go. All right. I'm going to grab my multimeter, turn it on to, let's do potential difference first. Potential difference is always easier to measure. So we'll go potential difference first. And I'll make sure I have got 2 wires to help me out here. All right, 1 and 2. So I'm measuring current. It tells me where to plug it in. Always ground it. I'm measuring voltage here. Always ground it. There we go. I've got my potential difference. So let's go ahead. And this, I want to find and see what the potential difference is. Record, you'll need a multimeter and connect circuit. You're going to go and correct now. Initial and final currents. All right, let's go ahead and figure out what is the voltage if I'm going to measure it right now. So if I'm across this switch, I want to measure the voltage across this switch right here. While it is open, while the switch is open, this potential difference is 1.96, basically 2 volts. So when it's open, the voltage is 2.0 volts. That's what the voltage drop is across this. Now they're all 3 the same type of light bulb, so I would assume it's 2, 2, and 2, and my battery source is set to 6, so that makes sense in terms of the loop rule. Positive 6, negative 2, negative 2, negative 2, back to 0. That makes sense in terms of loop rule. Let's change this over now into direct current, if I can. Where's my current reading? There it is, down there. It tells me, hey, move that, so I'll move this over here. Let's go figure out what the current is. In order to find the current, I need to separate this, and I need to get the charge to flow through my multimeter. So when I do this, you can see all the light bulbs are still on, and my current reading now says 0.16 amps. 0.16 amps. That is the total current, and then because I'm in series, I can assume that's the current flowing through each of these. So I can assume my power at each location, right? Each of these is 2 times this, so we're looking at like what, 0.32 watts of power being produced or dissipated at each of these things now, okay? Now, since we're already here, the next step in the lab is to close the switch and see what happens. So if I close this switch, let's see what happens to the current. As I close this switch, you just watched it happen. I'll open it, 0.16. If I close it, I see the brightness go up and my current jumps to 0.2. So when I close that switch, and now I've got more current, 0.2 amps. More current makes a little sense because I've now effectively removed this resistor. This light bulb goes off. So the current is actually flowing around that light bulb. I've created a short circuit, a pathway with less resistance through the switch, so that light goes off. So I watch my current increase. Let's remove my multimeter now from the circuit, rebuild my circuit, and let's go ahead while that switch is still closed and measure the voltage or the potential across that switch again in the same location. So now I'm going to go here and I want to see what is the voltage. It says close the switch voltage. While the switch is closed across this resistor, the potential is going to be hard to read, I think, unless I face it to you. But across this resistor now with it closed, it should say, it's giving me a reading, but what we can't really see is it's in millivolts. So this thing is technically 0 potential difference. There is no change in potential here, which means there's no transformation of energy taking place. Basically what it's telling us is that by closing this switch, the current is moving around this resistor, okay? What I can do, and that's indicated by 0 change in potential, right? If there was a change in potential, that would mean that there's work done on those charges. There's no work done, there's no power dissipated. If I come over here, though, to one of these brighter light bulbs, what I'll see is that this potential should be close to 3. Well, why is it 3? I've got 2 resistors that are lit up now. Each of these has a voltage change or a potential difference of 3 volts. 3 volts, 3 volts equals 6 volts, and that's my power supply is producing, okay? So this kind of makes sense. Now if I let the switch go, as soon as I let the switch go, what ends up happening? Those light bulbs dim, all 3 turn on, and my potential goes back to being 2 across this resistor, or across that light bulb, okay? So what happens when I do this? I'm changing where the current will flow. The last thing let's try is what would happen if I take my switch and I'm going to change it to a longer wire because I need to reach a little further. But if I take this switch and instead of just going around one of the light bulbs, what if I go around 2 of the light bulbs? So now this switch is in parallel with, I've got my first, let's see if we can see this, here's my first light bulb, here's my second light bulb, here's my third light bulb. But this switch now begins before the first and connects where it originally did. So now the switch is kind of going around these 2 light bulbs. And if I turn the switch off, let's see what happens. Let's see what's on the screen. If I turn this switch off, I notice that as I turn the switch off, I lose these 2. Both of these go off because now I'm short-circuiting both. Less resistance around this switch. And this one goes up way brighter in brightness. My guess is the potential across this one right now is 6 times the current flowing through it. That's the brightest bulb we have seen. And then as soon as I flip the switch again, I get a potential difference of 2, 2, and 2, which is 6. And I'm seeing the normal kind of light bulb there. Okay? You've got some questions about there in your packet. Go ahead and answer it in your packet. But this is the measurements you need for the series switch lab. If you got questions, drop in the comments. Send me an email. Ask me in class. All right? Till next time. See ya.